I have 4 pages, single spaced, with information that I want to cover today, so hang on to your hats. I'm starting this video with the assumption that you have your CNC, you have assembled your CNC, and you have acquired some sort of software that's going to allow you to create the code necessary for running the CNC, okay? There are 2 main steps that have to be accomplished with the use of software. You have to design something, and then you have to translate that design into G-code. When I was first getting started learning all this, I had no idea what G-code was. In simple language, G-code just pretty much is what your design gets translated into to tell the router and the CNC which direction to move. In order to program that G-code, you have to have software. So as I said, I am going to be using VCarve Pro. If you don't have anything yet, you're gonna wanna go either purchase something from Vectric, it's a very popular option, or you can just try out a free trial of Easel. Even Easel, if you look on the website, says like free trial can be extended after it ends. So you can keep using that perpetually as the free option, I think, pretty sure. And if you're watching this and have other suggestions for some free software options that work, feel free to drop them in the comments right now, because I think some people kind of scan comments for extra help, especially from people who have been doing this a lot longer than me. So drop a suggestion in a comment if you do know of a great free software option that you like, and maybe say why you like it. So if you're anything like me and learning to design from scratch in a brand new software sounds horrible, like it did to me, the good news is if you already design in, let's say, Adobe Illustrator or Photoshop or Inkscape. I use CorelDRAW, which pretty much no one's heard of, but I use it for my laser. If you already are familiar with the design software, you can continue to design in that, and you can export it to your new software, which will be used for creating the G-code and programming the toolpaths. So as long as you can export as an SVG, there's a variety of file types here that will allow you to turn it into G-code, you're set. So that's really good news. Another really good tip is, if you're not familiar with design at all, you can actually just go on Etsy, support a small business owner. There are a lot of CNC ready SVG files that you can purchase, and then all you have to do is learn the toolpath programming side of things rather than design and toolpath and G-code and all that all at once. So that's if you really want to jump in and get selling things quickly, you can buy designs. So keep that in mind. I know this is a lot of info. I really wanted to give you some context before we jumped into the step-by-step stuff. So what the heck is a toolpath? I heard that word so much before I got a CNC. Oh, you just program your toolpaths. Yeah, all you have to do is set up the toolpath. I'm like, well, I don't know what a toolpath is. Context clues tells you it's the path for the tool, right? Right, but what does that actually mean? It entails a lot of factors, and we're not gonna go into great detail on them right now, because I'm actually gonna share my computer screen here with you in a second and show you like a major cheat code. You ready for this? Okay, so here is the bit that I'm using for this project today. It's a 1/4 inch downcut spiral end mill from Tools Today. And if you go down on the page, you can see this right here. It has tool files for download that'll work with Fusion 360 and Vectric programs. So I told you I was using VCarve Pro. That's a Vectric program. So that's one benefit of using those software programs, that you can actually download the actual tool database right here, master Vectric tool file. You would just click on that to download. Here we go. So once you download that tool database, you would open up your Vectric software. You want to hit create a new file. But for right now, we really just want to access our tool database, and you can see it's not highlighted here. And so it requires you to just hit OK down here to then be able to access tool database from your toolpaths tab at the top. Like I said, I'm not doing like a full how-to video on Vectric because I don't know enough. Mark Lindsay, I'm telling you guys, go look him up on YouTube after you watch this video, of course. Thank you. All right, tool database. Now I have already imported the file that I'm telling you about here, but if you were to do it, you would come to this little folder. It says import a tool database. You would click on that. And like I said, guys, this is a major cheat code here. So this is important. You would go to your downloads, and I've clicked on this, to show you guys the example, but then you would select it, open it, and I think it might not show you it because I already have it imported, but a screen pops up right here and you just click on import. It's the leftmost button when that pops up. And then your tools will be all on this gigantic list. You can see I did it the same thing. I imported a tool database from Bits and Bits. And then down here is the Amana tool master list. So it's organized really well. You can click on the end mills to open that up, which is what I did. And then I opened up the 1/4" shank ones to find my bit, which is the 46202K downcut spiral right here. And when you click on it, okay guys, here we go. When everyone's talking to you about speeds and feeds and tool paths, this is huge. The manufacturers of these bits have essentially tested them to see what is a safe speed and a safe feed and a safe pass depth and a safe step over and all this information for you so that this is a good starting place. It doesn't necessarily mean these are the fastest settings, and you have to kind of do your own due diligence over time, but this is a starting point and you don't have to worry about it. So that's why this is an incredible tool to make good use of. So I want to highlight the Bits and Bits option as well, because if you go up to their downloads tab, tool library downloads, same principle here, tool library for Vectric, tool library for Fusion 360, same thing. You can download these, import them back into Vectric or whatever you're using with this import tool database button and get exactly what you need. And the reason why I wanted to highlight Bits and Bits is because they actually test their bits on Onefinity machines specifically. So if you buy from Bits and Bits, you know that you're getting some really accurate numbers. And I will say, if you just look at the suggested speeds and feeds on the website, they are way more conservative because they're supposed to be safe for anyone running any type of CNC, and not all CNCs are created equal. But then if you download the tool database file from Bits and Bits, you're going to get the specific recommended speeds and feeds that can be handled by a Onefinity, which is typically seen as a machine that can push a little harder and run files a little faster. So that's a big bonus for buying from Bits and Bits. Okay, so forgive me if I move a little fast through this. Hit pause if you need to on your screen, but I'm literally going to take you step by step through the process of designing a basic 4-inch square profile toolpath, what settings to use, and everything what to do in Vectric VCarve Pro. Let's get it. All right, you're going to want to, I'm going to hide this because it's messing things up. All right. Create new file. This is what I've set it up as before, 10 by 10 by 0.75. You can make yours whatever you want to be, but again, our end goal is to create a 4-inch square cutout. I'm using 3/4 inch plywood. I know it's not exactly 0.75, but that's what I'm putting to make sure the cut goes all the way through the wood. So if you want, you can mimic my settings. I put this, but I actually used a piece of wood that was more like 12 by 20. As long as your bases are covered, you're good to go. Choose inches, or if you're doing that other thing, you can do that. Good old millimeters. And I'm not going to go into detail with teaching you Vectric. I'm simply showing you how to do this cut to get you over that hump so that you can do one cut on your Onefinity and get that confidence boost you need, because I'm confident in you that once you learn this and run this one job, it's going to get the wheels spinning and you're going to be able to escalate your own learning in your own way. Okay, so I'm just getting you started. Okay guys, so let's just assume that these preset things are correct and hit OK. This is your drawing tab right here on the left side, and you need to draw a square. It's the very first thing you need to do. So here's your square right here, create a vector. And I like mine to be precise, so I just put in 4x4. It's already in there because I've been practicing running this for you guys. So you can do that and hit create, or you can draw your own. And if you want it to be a perfect square, you can hold in control. It's a good little tip. And that way it'll be equal on all sides. If you hit Control X, that'll delete. And if you want to relocate where this is on your workpiece, since this whole white area is mimicking your 10 by 10 piece of wood, go ahead and close that tab and find this transform mode, which really just means you can grab it and move it around. I'm going to put it in the bottom left corner. You don't want to put it all the way up against the corner because we're going to add tabs to our design, which is really just a way to hold the cutout to the material so that it doesn't fly out when it's done being cut out. And you'll see what I mean on that very soon. So leave a little margin and we're good to go. So we need to pull up our toolpath tab next. If you just rest your cursor over it and then go off of it, it'll keep disappearing. So I personally like to put this pin vertical and then it holds that in place. So it is time to program that toolpath thingy, which is where you tell the CNC how you want it to cut your wood for you. You're a boss, okay? So let's go ahead and tell it what to do. Basic profile cut is this button right here. It can be used for cutting parts out, or like what we're gonna do today, cut a square out, or it can still just be used for carving too. So it's a very versatile tool. So click on that profile toolpath, and we're going to go over some settings here and what you guys should be selecting to get going on your design work here. Start depth is at 0 means that you're going to be working from the top of the material surface. Cut depth, ultimately we want to go the whole way through the wood. So we're putting 0.755, adding that extra 5/1000th of an inch. Just to ensure that it goes through that full thickness. You wouldn't want it to cut and like end with another 1/16th of an inch. That would be really obnoxious. So it's good to make sure it goes the whole way through your material. And again, there's way more detail on all these settings if you go find Mark Lindsay on YouTube after this video, of course, and watch his stuff. He's an excellent teacher and goes into great detail about all these things. That'll work for now. Go ahead, and this is where you select the tool you're going to use. Mine is already selected because it's the last one that I used. If there's nothing here for you, hit select. And that'll bring up that giant database that you imported tools into, and you can choose whatever it is that you're going to use. It's already on the 46202K down cut spiral that I have from Tools Today. So I'm simply going to verify that this looks correct. I'm a beginner, so I don't know a ton. but I do know that it has 2 flutes. I do know that it's a 1/4 inch bit. And these are the recommended feeds and speeds, the famous feeds and speeds that everybody talks about. And before you have your CNC, you're like, what is a feed and a speed? This is it. Feed rate is 180 inches per minute. That's how fast it's going to move through the wood. And then the plunge rate is how fast it's going to go into the wood. 18,000 RPM, that's a good thing to take note of. I think a lot of bits do run at that speed, at least a lot of 1/4 inch bits, but the size of the bit is going to impact the speed it should run at. And that speed is talking about the actual speed dial on the router, which it goes from 1 to 6. So you're like, well, what the heck is 18,000 RPM then on a 1 to 6 scale? You can Google that simple chart just to keep in your work area so you know. From my research, I believe 18,000 RPM is somewhere between the 3 and the 3.5 setting on your router. Okay, so everything looks good. So we're going to go ahead and hit select. There. Coming back up here, it has automatically chosen 3 passes for us based on the information that we've given it. I'm going to roll with that. This part you can choose basically where you want the cut to happen in relation to this line. So it can go outside the line and give you those crisp corners of a square. It can go inside the line, and I'm guessing that would give you rounded corners, or you could go on the line. This seems the most easy for me to understand, so I'm going to go outside the line and just ensure those crisp 90-degree corners. I'm going to ignore these other little questions for right now. I think we're okay there. Adding tabs. Tabs are a safety check, basically. If you were to not program tabs, which are just little bits of wood that keep holding this piece to the rest of your workpiece, if you were to not program that, there's a chance that on the last cut, when this finally becomes free, it could continue rotating with the bit and become a projectile object, potentially. So tabs hold it in place. Double-sided tape is another great measure to consider for holding your workpiece down on your spoil board. So we're going to add tabs just in case we're a beginner. I've been told 0.125 is a pretty solid option for tab size in terms of the length and the thickness. You can, as soon as you click this box, if you come back over here, you can add them just by putting 2 here and hit add tabs. You can drag and drop them around if you want it to be over there. Usually across from one another is a good thing. I think 4 would probably be overkill in this situation. 2 is good. So we're going to roll with 2 and just hit close and be good to go on that. And the only other thing you need to do here is name it. When you're just designing this, it's really simple to design. So give it a good name that's very descriptive of what it is. It's a 4-inch square profile cut. And then if you tell yourself which bit you're supposed to use, that'll make your life easier. That's a tip I learned from people much more experienced than I, because once you save this, if you're using a flash drive, you take that flash drive out to your machine and you might not have your computer with you to reference the job that you're running to be able to see it. So it's good to just reference what bit you want to use for that as well. So 1/4 inch end mill, something to that effect, as long as you know. And then you're going to calculate. This is the part where you actually calculate the toolpath and the G-code. So this is just a warning that comes up every single time if you make that cut depth thicker than your material. It's going to be like, hey, just a heads up, this is going to cut through your material. So make sure you don't have metal or anything underneath it that it could damage. Hit OK. This is the absolute fun part. This is where you get a 3D animation of what you're creating. And the awesome thing is, if you don't add tabs just for the simulation purpose, you can actually remove the scrap material and save it as a JPEG. So if you need to show a client for instance, this is how your project is going to look to get that final approval, this is a great way to do it. It's cool because you can rotate this and see it in its 3D form. The best part is you can hit this button right here, you can preview the selected toolpath. We only have one here, but okay, that went super fast. Let me slow it down. This is a speed dial here. If you slow it down, hit reset the preview, basically a rewind button, and preview it again. Moving slower, it shows you your bit, shows you the cut path, and shows you exactly what it's going to look like. And that's the best way to double check yourself. This is a built-in safety feature to say, hey, did you program this correctly? You can see the tabs that are there. And I just think that's so fascinating that you can see basically what the machine is going to do. So what I was saying earlier was if you do a simulation for a client, don't put tabs on it. You can double click on that material if you don't have tabs, and it'll disappear so that you can show just the piece that's left. And then you can go up here to view and save shaded image. And that basically is what allows you to just shave it. We're not going to shave it. We're going to save it. That will allow you to save it as a JPEG or bitmap or whatever. And that's what you can show the client to seal the deal. So that's a really nice feature if you are a Vectric person. Okay, so this is it, guys. We've designed a square and it looks good. And so the only thing left to do is to close that out and use this Save Toolpath button right here. Make sure you have it selected. That might be enough to highlight it, but just double check. I'm gonna click my box, then hit Save Toolpath. And this information is already in here for me because when you install Vectric for the first time, it says what machine do you have, what model, and that way that helps communicate with your machine properly. So just verify and make sure that's in inches, not millimeters, since you programmed it in inches, or I did, and then you save the toolpath. And for me, I don't have my CNC connected to our Wi-Fi yet. That's a goal. It's going to happen. So for right now, I'm saving jobs to a flash drive. So you would just find I don't have one plugged in right now, but you would find the flash drive and just save it as you normally would. And then also just make sure you do a regular file save as for your project in general, in case you ever want to come back and make any changes to it. And that is that. You've just done your first design, set your first toolpath, got it programmed thanks to that downloadable tool file database. And now it's time to actually go to the CNC and run the job. So I hope you're pumped. It just helps to get in that mental space of, I can do this. And once you do it once, I think it really gets you excited to learn more and gets you to that next level of learning and creating. So let's do it.